Hello, everyone. Welcome to my presentation. It's my first Black Hat, so I'm very happy to be here today. Today, we will talk about what's hidden behind closed doors and how can we bypass RFID readers and physical access control systems. But before we start, a little disclaimer. When we talk about physical access control security, we always have to have a lot of things in mind, and we cannot only focus on RFID readers, on locks. We have to take everything into account. And this is my first question for you. Do you see any problems with this door already? You can raise your hand if you have any idea what could be wrong here. There is this hint with this red arrow. Okay, another hint. So who knows what this tool is? I actually have it here with me today. As you can see, it's a long wire with a lot of tape. Yes, I managed to go through airport security with it without problems. So, does anyone have any idea how can it be used? What's the name of this tool? Raise your hand if you have. Okay, I see some raised hands. So, the name of the tool is Under Door Tool. And as the name suggests, we can use it to open some doors. So, as you can see here on the video, I wanted to go for this door, but there is no handle on my side. But by using the gap that's between the door and the floor, I'm putting the tool below the door, and I will try to catch the handle on the other side with this wire. And as you can see on the right side, there is actually an RFID reader close to this door. But I completely ignore it because there was an easier way to get inside, and I didn't have to play with RFID stuff. So let's take a look how it works. And as you can see, I managed to open this door and break into my boss's backyard in this way. Thank you. So as you can see, I'm very proud of myself at this moment. It was my third try ever using this tool. And yeah, I chose the easiest way to get inside. Why? Because I'm a red teamer. So my name is Julia Zdończyk, and I work as an IT security specialist at Securing, where I perform penetration tests and physical red team assessments. But my true passion is finding new hobbies to get adrenaline rush. For example, horse archery, that you can see here on the picture, or trying to get adrenaline rush through breaking into different server rooms that I shouldn't get into. But I managed to let myself in, and today I will show you some ways how to do these kinds of things. So, RFID stands for radio frequency identification, and I'm sure everyone used it at some point. Either it be clothes tracking or contactless payments or access control systems, but there are also some more interesting uses for this technology. For example, on the left picture, you can see a coffee filter. As you can see, below is a flipper. That's a device that can read RFID tags. And there is actually an RFID tag inside this coffee filter. Why? Because the producers of coffee machines don't want you to buy unoriginal filters. That's one of more evil uses of this technology, I would say. And on the right side, we can see a road sign. Apparently, it got stolen pretty often, so they had to install an RFID tracking inside, whatever that means. I have no idea why it would be stolen, though. And yeah, there are some other interesting things with RFID inside. We can take a look. So now we'll switch to camera. Yeah, so that's my setup here. And for example, we can have an RFID button to track linen, or some RFID tags, RFID stickers. Also, I had an RFID syringe, but apparently you cannot travel with syringes in your luggage. So let's go back to the presentation. And if you heard about RFID, you probably heard also about RFID card cloning. Maybe you even tried it at some point with Flipper or Proxmark or other stuff. And the thing with card cloning is that sometimes it works. For example, if the system is not very secure, it may be, for example, a prox card, a low-frequency type of cards that use no encryption. And if the employees don't take care of their cards. So, for example, they leave them unattended on tables during lunch break. In these cases, it is very easy for us as red teamers to scan someone's card and get inside. But we won't always be so lucky. For example, if the system is configured well, it may be a CEO's card with non-default elite keys. It will be very hard for us in a red teaming scenario to clone such a card. Also because oftentimes we only have a few seconds to clone someone's cards. And these cards use encryption. So we need to know keys. And in these cases, someone sometimes will get lucky, like in this case, where someone left their card permanently attached to a reader. Yeah, I guess it was very convenient for the employees of this company. For me, it was very funny when I saw it. But we won't always be so lucky. And this got me thinking, what are the other ways in which we can bypass RFID access control systems to get access inside? And for this part of the presentation, I will divide access control systems into two types that we can meet in the wild. First one will be autonomous RFID locks. So how do they look like? We'll have a door in the system that's the barrier between secure and unsecure area. And close to the door, we'll have a reader. The reader will communicate with tags via radio frequency. That's the dashed line on the schematics. And when the reader gets the ID of the card, it will decide if the card is valid for this particular door, and it will decide if it will open the door. So in case of autonomous RFID locks, the whole decision-making process happens inside the reader. So the reader has a memory of valid cards, and it decides if it will open the door. And how the systems works. So I have an example of such a system here with me on the stage. So there are two ways to add new cards to those autonomous RFID locks. First one will be using a specific manager add and delete cards. So let's take a look. Here is my reader. And this reader works with MyFair cards, MyFair Classic cards. Here is such a card. And now look closely at this light. I hope it will be visible. OK, so maybe you heard the beep. The reader opened. So this card opens this reader. Also, it lights up green, but I don't know if it's visible. Very good. And now we'll try to delete this card from the system. So now I'm in the deleted mode. I deleted the card. I'm getting out of the deleting mode. And now I will try to use it again. It no longer opens the lock. The LID didn't change. So that's a very basic operation. But there is also another way to add new cards. And as you saw, this reader has a pin pad. And of course, when you meet such a reader in the wild, you can try to look for a reader's manual and see if there is any default code for those readers. So it's very simple. You can just try to enter the administrator setting and add your own cards to the system. But there are also some more interesting vulnerabilities that may happen in those readers. For example, a logic bypass of the lock operation. And by that, I mean a card that would always open the lock, even if you try to delete it from the system. And it will be a little exercise for you now, so focus. So let's take a look at how this works. So every card has its data that will be used for authentication. In case of MyFair card, it will be just an identifier of the card. It's in hexadecimal format. An example of such an ID is on the slide. And it has 4 bytes. And now, does anyone have any idea which ID would be so specific that it would always open the lock? Raise your hand if you have any ideas. I see someone talking there. Do you have any ideas? 000? OK, we can try that. That's a good idea. OK, so now we will try to create such a card. So the device I have here with me, it's called Proxmark with Iceman software. And we will use this device and this card that allows me to change ID of the card to try the 000 option. Here is a command center for the Proxmark. And now I will use this command to change the ID. I need to, OK. So we tried 0000, right? OK, now this card should have all zeros. So let's check if it works. OK, it does nothing to the reader. The reader does not recognize it, and it doesn't open. So that's not a good idea, but it was a good guess. Anyone has any other ideas? All Fs. OK, so we got the lowest value in the system, all 0 bits, and now we'll try the highest, all Fs. So let's try with all Fs. Okay, and let's see. Let's take a look. Did you hear the beep and did you see the LED light up? So it opened, but you may say I added this card to the system before the presentation, right? So let's try to delete it from the system. This is the delete card. So now we are in the deleted mode. Delete card again. And now I will try to use this card again. It should be deleted from the system. But it opened the lock again. As you can see, I cannot delete this card from the system. Why? Probably some software bug. Maybe the value of deleted cards change automatically to all Fs in this kind of devices. So yeah, as you can see, there are some more interesting vulnerabilities, and you can just go around with this card with all F ID and try to open some locks. Maybe it will work in other ones as well. Okay. Another problem that may happen with those locks is EMP generator, electromagnetic pulse generator. Basically, this device generates a very strong electromagnetic pulse that can do some strange things to hardware. Sometimes it can reset the memory of the hardware. So let's look at the demo of the device operation. So here you see this known reader, and I will try to use the EMP. As you can see, it opened the lock very quickly. And now, why don't I do the live demo of this? It can fry the locks. And once I tried to do it on stage, and I almost fried the audio system. So I no longer try it live. Also, we have another video of the sellers of the device when they are opening different locks in the wild. But as I said, it's very unreliable. Sometimes it will open the lock, but in other cases it will fry the lock and no one will get inside, and we don't want that, so I do not recommend trying it during red teams or in the wild. It's treated as a curiosity. And what are the other ways that we can get inside past those autonomous RFID locks? Well, if you are desperate enough, you will always find a way. And we can try this as well, especially if we fried the lock and we really need to get in. But yeah, there are some other problems that may happen. For example, as I said, the lock is a decision-making unit, and the lock sends the information to the door lock, the physical lock, to open or close. And sometimes we can try to take this reader off the wall and cut the wires leading to the physical lock. And if it works, if safe open mode, the lock will open when we cut the wires and open the circuit. So there are many, many problems. Another type of systems, because the autonomous RFID locks that I talked about earlier will mostly meet them in low security areas like flat apartment buildings, maybe some entrances to staircases. But when you go into actual organization facility, in most cases you will meet a system which has another element. So let's take a look at that. In case of this access control system type, we'll also have a door. That's a barrier between secure and unsecure area. We'll have a reader close to the door, and the reader will communicate with card over radio frequency. So far, everything works the same. But in this case, the reader does the authentication process and the decryption process of the card. But as soon as it gets the card data, it doesn't make any decisions. It doesn't have a memory of valid cards. It sends the data to another unit called controller over wires. And the controller is a decision-making unit. So it will decide to either open all or close doors. And now we'll take a look at this communication channel here between a reader and the controller. So in most cases, what you will meet will be called Wiegand. That's a very old and very simple protocol. Basically, in Wiegand, you will have two wires going out of the back of the reader, in most cases, white and green wire. And how it works, basically, the both lines are in high state, and whenever one of them drops low, it sends a bit of data. So when the white line drops low, it will send 1 bit, and if the green light drops low, it will send 0 bits. And the ID, or authentication data of the card, will be sent this way. What's the problem with this protocol, though? As you could see, it was very simple, and it sends the ID of the data of the card. And it sends the data of the card in plain text. So let's take a look at that. No matter how complicated the decryption process is between the card and the reader, how many encryption layers there are, as soon as the reader gets the decrypted data of the card, it sends it over Wiegand without any encryption at all. So as you can imagine, we can leverage that as a red teamers. So let's do a little red teaming exercise, and let's imagine we're trying to do a red team assessment. So first step that we'll do, let's say I was tasked to bypass access control system in some facility. First thing I will do, I will check what type of system, what type of cards is used in this facility. So in my case, I actually have an access control system here with me. I will show it later on the camera. Let's say I did some observation phase and I managed to take a photo of the card of one of the employees. That was the photo. So as you can see, it was very easy for me to understand what type of cards is used because it says on the card, CO's card. And now what do we know about those cards? As I mentioned earlier as well, these cards are very hard or very expensive because you need specific tools for that to clone during red team assessment. So for us, it would be very hard to get access to this card to find the encryption keys. We don't want to do that during a red team because we don't have that much time. And the real credential, the real data that is used for authentication is encrypted inside the card. So maybe we can try to use our knowledge about Wiegand and run another attack, trying to sniff the communication of the Wiegand. And actually, it's nothing new. It's been done before. We have some tools that we can use for sniffing the Wiegand communication, for example, ESP key or Bluetooth Low Energy key. But also, my colleague, Jakub Kramasz, created his own cool tool called the Tick that I had the pleasure to contribute a little bit to. And now we will take this tool and we'll try to install it on the wires to listen to the communication and get the ID of the card. So let's take a look at my setup here. So what you can see here, it's a little access control system. We have a reader, we have a lock, we have door that is closed now. And on the other side, we will have our controller, which in this case is a Raspberry Pi with some Python code running. So first step, we want to get access to the wires, right, to install the device. So we need to take the reader off the wall. Normally, there would be a screw underneath the reader. I already unscrew it. So let's try it, right? Let's go and take the reader off the wall. Oh, do you hear this sound? That's not good. It was an alarm. So during corrective assessment, we cannot always just go close to the reader and try to take it off the wall because we might get caught. In this case, it was a beeping alarm. So here is a little sensor. As you can see, when there's nothing over it, it triggers an alarm. I can easily disarm this alarm because I know it's only a beeper. There are those cables tangled together. When I untangle them, now it should be disarmed. So as you can see, it no longer beeps. So let's talk a little bit about tamper alarms. So this is a close-up of the reader and the tamper sensor. So basically, on the back of the reader, oftentimes we'll have different types of tamper sensors. It may be an infrared sensor, or it may be a physical spring that will touch the backplate of the reader. So when you take it off the wall, it will open the circuit and trigger an alarm. There are different ways to implement this. The case with alarms, though, is that the tamper attempt being detected is sent over the wires. For example, here it will be a violet wire. And who would bother connecting those wires if it's not necessary, right? You just want your system working at your company. So oftentimes they won't be connected to anything, and we don't have to worry about them when we go into the assessment. Another thing that may happen It may be only a beeping alarm, like here. So if there is no one close to me, I can take it off the wall, disarm it quickly, and go further with my assessment. Also, another thing that may happen, if they connect the wires, it may just go to some logs that no one never checks. But be aware, if you ever try to do those things, that there are temp alarms and they may be configured well. So let's continue with our assessment. So let's say I was lucky because there is no one here, I'm here alone. So no one caught me taking this reader off the wall. And now we will try to install the TIC. So we want to get access to the wires. We see the Wiegand wires, white and green, and the power wires. And now I have the TIC with me here. So let's connect it. I will start with the Wiegand data wires. These are these connectors here for that. And we'll go with green first, and then the white wire. So let's try that. It needs a little precision, but if you know how to do it, you can do it very quickly. Okay, I guess it went in, I hope. And now we'll connect the power to the device. So another connector. And let's take the red and the black wire for the ground. Okay. Almost got it. I hope you see the emotions the same as I feel them right now. Okay, I got it. Okay, I managed to connect it. And as you can see, some LEDs are blinking on the device, which means it works. So now we connected our TIC. And what we would do during red team assessment would put it inside the wall again, so that no one sees what we did. So let's do that. Also, as you can see, there is a lot of things like these connectors, also a little screen with the TIC as well, because it's a demo setup. We also have options for making it a little bit smaller if we need to fit it into small spaces. Because sometimes you will have a lot of space behind the reader to hide those things. But sometimes you will have only a very small space. So let's put it into the wall. And the reader is installed. So let's see if it was successful. So now the TIC should turn on the Wi-Fi, and it looks like it works. So this is the dashboard of the device. Let's take a look at the dashboard. And while it loads, we can see that there are these two lines on the schematics. So the green and the white, which tells me that it worked and it has connection with the wires. So let's say I install it, and then I wait. I wait for the actual employee to come and authenticate to this reader. So let's say that I was waiting, and the employee authenticated to the reader. So as you can see, it opened the door and works. And now what can I do? I can check if I got this information on the TIC. So in the meantime, we can take a look. So basically, we'll have this little interface where we see the Wiegand data, the format of the card. It tries to count the facility and card number, which is a part of the card data. And if it works, as you can see, we got a lot of data, and we'll try again. Sometimes it doesn't, well, it's very moody today, but give me a chance. Well, it's a work in the process. I added some code to the device a few days ago, so maybe it made it a little bit slower. And I will check if I connected to the network. I should be connected. Let's hope the demo gods will be on my side today. And I'll check the setup on the other side to see if it works. Okay, it worked. Great. Thank you. So let's look if we got any actual data. As you can see, there is a little bit of rubbish here, but we can actually see an actual recognized ID of the card here. So we got the card in a format H10301, and here is the ID of the card. So we managed to actually get the decrypted ID of the CO's card. So what can we do now? We can try to open this reader remotely because we have the device on the wires. So we will send the ID. Look at this lock now. It opened. So now I can open this door remotely whenever I want. Okay. Thank you. Yeah, I've been trying this a few times and always it worked the first time. So I felt a lot of emotions right now, but as you can see, it is reliable, even if we have to wait for a few seconds. Okay, so now I can open this door whenever I want. It's great for me because my attack worked, but it's not ideal because there are many doors in the facility. And let's say I installed this device only on some door to the staircase or the back door to the building. And I want to get inside the server room because that's what I'm most excited about, right? So what can I try to do is, instead of installing this device on every reader, which would take a lot of time and a lot of equipment, I may actually try to do a clone of the card. But how? You remember, as I said, that we cannot really clone the CO's card. The first problem was that we don't have the key to decrypt the ID of the card. But now we have the real ID that the reader decrypted for us. But we still cannot make a clone because we would need to encrypt it on the physical card for it to communicate with the reader in a working way. But maybe someone left some legacy settings turned on. So we can try to see if the reader supports any other card types. Maybe we can leverage that in some way. So let's check if the reader supports any other frequencies, because there are two main frequencies on which cards operate. It will be low and high frequency. And this device, it's called RFID, RF field detector. And when we put it close to the reader, we can see two LEDs turning on. The first one is for high frequency, and the second one is for low frequency. So I can actually see that this reader supports both frequencies. So maybe there are some other cards working with this reader besides CO's cards. So let's take a bunch of different cards and try them on the reader and see if any of them does something. So I will try with Myfer, which is also a high frequency card. But it does absolutely nothing. The reader does not communicate with the card. But I can try a prox card, which is some low frequency unsecure card. Did you see that? The reader beeped and it turned green. Obviously, the card does not open the door, in this case, because it was not configured for this door in the system. But we now know that this reader supports prox cards. So what does it tell us? As I said, we got the real decrypted ID of the CO's card. And we would want to present this ID to make a clone of the card. We cannot do this with CO's card because we cannot encrypt it. But with prox cards, they are insecure cards that don't use any encryption. So basically, we write the raw ID to the card, and it's sent exactly in the form that we wrote it to the card, to the reader, and then it's sent in this form over the Wiegand wires. So what we can try to do here is a downgrade attack. For this, we need to have both types of cards working, some secure card that we want to clone and some insecure card. In this case, it's COs and prox cards, but it may be other types of cards as well, as long as there are the legacy settings turned on. And now we'll take the decrypted ID of the CO's card, put it on a prox card, and send it in this exact form to the reader and then to the Wiegand. So let's try that. So we will take a look at the Proxmark device as well. And we'll try to write this ID to the card. So let's take the ID we got from the tick. And let's try to write it to the card. OK, we can see if it was successful. OK, as you can see, it's the exact ID of the CO's card. So now, if it worked, I should have a clone of the card that will open this door. OK, I hope you see it good. So I will try to open this door with a prox card. Will it work? It worked. So now I thank you. So now I have a working clone of the card. And what the upside of this is that now I can walk around the building and open different readers with this card as well, not only the one with the tick behind it. And we can try to see. OK, so here was the previous attempt with this card non-working when I was checking if any other cards work with this device. You can see the different ID, and it was not opening. Now I changed the ID of the card to the one of the COs, and it got right like that. So as you can see, it's the exact same number as the COs. We can try COs card. Let's make it close. And now the prox card. And it should look exactly the same. Yeah. They're actually down here. OK. OK. So we got those cards working. And now, all good. And at this point, you may think, OK, it's not very good because we installed some expensive readers in our facility. We have these cards with a lot of encryption that were very expensive. And we wanted to be secure, right? We did everything right. But now everyone can just go inside, install this device behind our reader, and get access to our data and open all the doors. Well, of course, there are other solutions. For example, OSDP. Open Supervised Device Protocol. So the thing with OSDP is that it supports AES encryption. So good, we no longer have cards flying around the facility. But the problem is that it supports AES encryption when secure mode of operation is used. So you actually have to turn it on for it to work. So what we can sometimes meet is an OSDP system that works without any encryption. So it's basically the same as Wiegand. We can just intercept the communication. And cool, I can walk around the facility. I can try to plug these devices into the wires, right? Well, there's one more step on the way. It would be very hard to install this device because it's very suspicious. As you saw, taking the reader off the wall, installing all of this, it takes 1 or 2 minutes, depending if I'm lucky. So maybe I can try social engineering to get inside. And I'm sure some of you heard the stories that you can get everywhere with a ladder. And it's actually true. So this is me on this photo with this very professional disguise. So I was acting as a server room technician. And I really wanted to get into the server room. And actually, I managed to go through one of the reception desks with that disguise. So yeah, mission accomplished. But you don't always have to use such professional disguise to get inside. All you need to have is a lot of confidence. And here on this video, you can see me trying to open server room with a plastic card. I'm trying to put it between the door and the door frame. And I managed to open the server room in an unauthorized way in a few seconds. But what's the clue of this video? I did this in the middle of the day inside the office when there were employees walking around. And they didn't know that there is a red team happening. All I did was smile, laugh, act very confident, talk with my friend who was also a red teamer, and maybe they looked at me strangely, but no one came to me and asked me what I was doing. No one went to grab the security guards to check what's happening. I could walk around the facility doing whatever I wanted. And what if I told you that not only can I walk around the facility trying to open different doors, I can actually try to stop you from opening your doors inside your facility. And how can we do that? So let's imagine a situation. I managed to get inside the server room with this plastic card or a metal hanger. That also happens once that I open the door with a metal hanger. And now I'm installing some devices inside your server room. But I don't want to get caught. I don't want anyone to get inside while I'm there. I can try to use the tick again. So there is a denial of service mode in the tick that we can use. And we'll try to do this now. So I can basically flood the data lines behind the reader with random data. And now, when I try to open this reader, let's say some employee wants to open this reader with a valid card. It's the CEO's card that I used earlier. As you can see, it no longer opens. That's my clone of the CEO's card. It also doesn't open the door. As long as I'm there, I can put it into the denial of service mode, and no one will get inside. And then maybe they will go away to check something in the controller or in the system, and then I can sneak out. Also, there are other ways that I can try to do that. So the case with HID readers, if they are unpatched, and we'll often meet unpatched readers, as you can imagine, sometimes they have Bluetooth enabled, and you can connect to them via HID Reader Manager app. And there is a vulnerability with that. So here you see a screenshot of HID Reader Manager app. And we have two options to use on a reader, inspect or locate. And when we inspect the reader, it will blink, it won't give any sound, and it will not authenticate any cards for about 8 seconds. So if we put it in a loop, we can basically do the same what I did with the tick now. But there is also a more interesting case, the locate mode. In the locate mode, the reader will beep loudly, blink, and will not authenticate any cards. So if I put it in a loop, the reader will beep, and I can use it as a decoy. So let's say I want to do something in one part of the facility, and I don't want anyone noticing. I can put every readers in another part of the facility in the locate loop, and they will all beep, and they won't accept anyone. So now you have employees that cannot go anywhere in that part of a facility. You have a loud noise, no one can work comfortably, and hopefully all the security will went there to check what's happening, and then I can do my thing in other part of the organization. And now we talked about a lot of attacks that may happen with access control systems, but what can we actually do to secure those systems? So here is a few ideas from me. First, always place access controllers in secure areas. So as you saw in the first part of the presentation, we talked about autonomous RFID logs. And in this case, they were the decision-making unit. So we may call them controllers in this case. And they were on our side. So we could take them off the wall and cut the wires, opening lock. Or we could use electromagnetic pulse generator to reset their memory and open the doors. We don't want that. We want to use the system with a separate controller somewhere in the secure area where no one has access to it. Also, we want to use more advanced solution, so OSDP and not Wiegand. And we want to configure it well with a secure mode and encryption. We want to use proper tamper detection, connected and alerting security guards, so they will come to the reader that was taken off the wall immediately. We want to keep the reader firmware up to date, so I cannot run the denial of service with Bluetooth with HID Manager app. We want to disable legacy credential, so no one can run a downgrade attack. And many, many other things as well, because as you saw, no matter the protections, you always have to look at the whole system. And does anyone see a problem with this picture already? I know there is a glass door, but it's not a problem. Let's take a look at that. It's also the gap, but this time not below the door. And maybe you remember us at the start of the presentation, I told you that I like finding new hobbies, like climbing. So I try to use this skill during this assessment and get through the gap over the door inside the office. And yeah, as you can see, I'm still alive, so it worked. And I managed to get inside in this way. So, a little key takeaways. Physical access control systems are oftentimes insecure, so take that into account. And physical red teaming is a service designed to check for these vulnerabilities that are otherwise often overlooked, because it's very hard to check physical systems. With app application apps, you can just send access to pen test teams for them to test that. But with physical red teaming, you have to have a team in place. And also raise awareness, educate, and learn, because as you see, there are many problems with the system, and it's always shocking for me how often they are very insecure in very advanced organizations. Sometimes it will be very easy. I can just quickly clone someone's card and get inside without any problems. So yeah, learn about them, educate other people about what you heard, and raise awareness. So that will be all for me. Special thanks to everyone who helped me with the presentation. Sławomir Jacek, who does great trainings about RFID security. Jakub Kramasz, who created the TIC. Maciej Miąskowski, who is a great supporter for me. My dad, who helped me create this setup. So actually, when you take a look, you can see a part that I tried to cut and a straight line that he did. It was my first time with woodcutter, and I still have all my fingers, so it was a success. And also, special thanks to everyone who puts their time and effort into physical access control systems, security, and research. And there is a lot of people who do great work in this area, and you can watch a lot of presentations from them online and learn about the systems. So, thank you very much. If you want to connect or learn more, you can connect with me on LinkedIn. If you want to have a physical test, I would be very happy to do them here or in another country, because we do them abroad as well. And I would be very happy if you could rate the presentation to let me know how it went. So thank you very much for today.